If you are looking for someone to help you with your programming homework or assignments, our website, Programming Homework Help, is the best choice. We can claim ourselves as the best programming homework website because we count with multiple experts with many years of experience. This way, you will be able to hire a programmer that guarantees the completion of your assignment with high quality and in a very short time. My name is Elena and I am a tutor at Programming Homework Help. To demonstrate the high quality of our programming work, in this occasion I will show you some programming exercises in MIPS assembly. In this code, we will present 5 different MIPS assembly programming exercises and how to solve them in detail. For problem 1, we want to determine if a given temperature belongs to one of the two temperature ranges. In this case, we selected the ranges from 20 to 40 degrees and from 60 to 80 degrees. We will use a test temperature, but we can also add a command to ask the user for the temperature. If our register 3 is equal to 1, indicates that the temperature is in the allowed range. We assemble the next part in the text section and we make the main function values available for other sections. This add the instruction saves in the register 8 the temperature value, because register 0 always holds the value 0. SLT tests if a variable is less than another one. In this case, if register 8 is less than 20, register 9 will be equal to 1. If not, register 9 will be equal to 0. BNA tests if register 9 is different from 0. If it is, it will go to out-of-range function, where the value 0 will be assigned to the register 3 to indicate that the value is out of range. This specific SLL function is also called NOP or no operational function that causes a delay in the program. BEQ tests if register 8 is equal to register 9. If this is the case, we will be directed to the inRange function, which changes the register 3 value to 1 to indicate that the number is in range. Now that we explained these functions, we can see that all sections have the same function, but for different ranges. So we can see that the program tests the number in each section where the program ends as soon as we obtain the value for register 3 independently on the result. In problem 2, we want to fill an array of words using a loop. This will be done by storing a number in each 4 bytes of the data section from the value 0 to the value 24. We start defining a data space and an array with 100 bytes. Then we assemble the next part in the text section, and we make this main function's value available for other sections with this global function. Now, defining the main function, we start loading the upper address of the array, then giving a value of 24 to register 9, and we will use the register 10 to save the current number to add to the array. In the first loop, we are counting the 4 bytes we mentioned earlier. In the loop 2, we save the value register 10 in the array of the register 8. Then we advance in the array and we will be directed to the loop number 2, again until filling the 4 bytes with the same number. The next part will increment the value of the number to save in the array and will take us back to the loop again until getting the value of 24. Problem 3. This program reads an array and removes the spaces. We start defining the data space and our string, which will be a zero-terminated string. That means we won't use ASCII, we will use ASCIIs. Then we indicate that we are assembling the next part in the text section, and we make the main functions available for other sections. Now, in the main section, we start loading the upper address of the string in the register rate. Then we load the ASCII value for space in register 9. Then we enter the first loop, in which we will check if we either are not on a space or if we are at the end of the string. Depending on this, we will be sent to one of the next functions that advance to the next character and send us back to the loop, or finish the program. In the second loop, we replace the current character by the next and we advance to the next character until reaching the end of the loop. Problem 4. This program will add the numbers into arrays, then store the result in a third array. We start defining the next functions in the data space, which will also expect 7 expressions for each one of the next directives. We indicate that we are assembling the next part in the text section, and we make the main values available for other sections. The first part will load the addresses of the 3 arrays in the registers T0, T1, and T2. Then load the array size. The loop will load a word from the first 2 arrays, and then will add both on the third array. Then we will advance to the next position in all of the arrays. Then the size will decrement until it reaches 0, and the loop ends. Problem 5. In this problem, we want to calculate the miles per gallon a car can travel when the user gives the miles and gasoline consumed. First, we define our data space and some of the instructions for the user that will be printed later. We ask the user to introduce the number of miles and the gasoline consumed, and then we return the miles per gallon. Then we indicate that we will assemble the next part in the text section that corresponds to the main section. As in the previous problems, we make main values available for other sections. In this main section, we will use system calls for different purposes. In this case, print strings, read integers, print integers, and exit the program. LA will load the address of the prompt1 string in the A0 register. Then we set a system call for that we will be able to print the string. Then we use the system call function here. Then we change the system call value to 5 to be able to read an integer value. Then we save it in the T0 register. We also added these 2 lines in case the user gives a value of miles of 0. So it finishes the program. As in the next 6 lines will do the same than the first 6 ones. But for the case of the second number given, that corresponds to the number of gallons that will be saved in the T1 register. These next 3 lines will load and print the next string in which we will indicate the result of the calculation. Then we start the calculations using the division function and the 2 registers in which we save the values of the miles and the gallons. We set the system call to 1 to print an integer, and we call the function to print the calculation obtained. In the next part, we just load a new line string in the register A0, and we set the system call to 4 to print the string. Here we have a line to repeat the process indefinitely, to be able to make more than one calculation. Here we finish the 5 exercises in MIPS assembly. You can trust that our programming homework help is legit. In our website, you can find the reviews from many people who have hired our programming homework help services. We hope this video was useful for you. For any assistance, you can visit our website programminghomeworkhelp.com or send an email to info@programminghomeworkhelp.com. Thanks for watching.